That starts on page 309. The pictures in your architectural book, excuse me, your architectural book, are a little better than what my copies are. Page 309 in your architectural text. We've already covered some of this, and so I'm not going to try and re-hit the stuff we hit in architectural when we were dealing with site plans. What I hope to do here when we're covering property boundaries is understand how the survey system for America was set up and ran. And it's used in this same system throughout a large part of the world. Not everybody's on it, but the majority of people are on our planet. So when we're talking about defining a piece of property that we are going to do a task on, the first thing we have to do, obviously, is locate where these property boundaries are. And we locate them two ways. One, we locate them in the office, that's us. We also locate them in the field, that's our survey crews. Remember, survey is really measurements on the earth, that's what that means. But we have to do those two things. Now, for the office, when we do it, we're really only going to use two measurement systems that define property. We have a lot and block, which is what happens when we are in a municipality, where a city has taken control of that and they've divided it by subdivisions. Behind the lot and block, though, every piece of property has what's called a meets and bounds legal description. You don't see that meets and bounds when you are in a lot and block system, or not all of it. Anytime you're out of a municipality, that is the only system you're dealing with. Now, I want to start with the basic and say, where does this system come from? So, where do we start with it? We start with Flint. So, most of you probably know, way back in the seafaring days, who knows the date of it? I think the Phoenicians or Vikings or those people started all of this. You have meridians and parallels. These also have terms called latitudes and longitudes. Which one's the latitude, which one's the longitude?
Latitude.
Okay. Yeah, I always remember it. Parallels is latitudes because it looks like a ladder, right? You can climb. My old kindergarten teacher told me that, and it stuck with me all my life on that. And so then, if this is a latitude, this one has to be a longitude. Now, these terms are somewhat going to go back and forth. You will also see parallels called a baseline. A baseline. The thing you can really kind of think of is when you are on our planet and you are on one of these lines, you are, in fact, in a true spot. It is a known spot on the planet. If you are not on one of these lines, you really are kind of guessing. The scale is warped. And it happens when you take a sphere and try and open it up to a flat surface, you get warped surfaces in there. Okay, now they've come up with ways to kind of minimize this warpness. Now, before we go, these each have a baseline, or a base, or datum. I guess that's the correct word. I don't want to use baseline because a parallel is a baseline. A datum. What's the datum for a meridian? Does anybody know what that is?
The primary.
What's our primary datum for a meridian or longitudinal line? Somebody in the back said it.
The primary.
Okay, and where's that at?
0 and 180.
It's at 0.
Greenwich.
There you go. It's the Greenwich meridian. So it's over in England, right? And in fact, I was watching the Olympics 12, 13, 14 years ago or whatever, and they made a big point of the one in London. They showed it, and it's basically, they've got it all bricked and everything, so you can see it. But that's our datum. It's over in England.
What do you call it? Is the base meridian?
The Greenwich meridian.
Greenwich meridian, okay.
Okay. I don't know if I pronounced that right.
Greenwich.
Greenwich.
Oddly.
For a parallel, what's our datum on this one? Or a latitudinal line?
Equator.
Okay. Very good. Equator is. Okay, so you figure you're on any of those lines, you are true size. You get off of them, and these kind of depict what's happening. So I take this sphere and I try and lay it out into a map flat. then my scale, as long as I'm on one of these lines, remains true. But what happens to these zones right in here? Okay, they're getting warped. So that's the issue we really have to deal with here. Now, this is too big for us to deal with on a piece of property, so we got to start breaking this down. And what we do is we look for the intersection of a longitudinal line with a latitudinal line, and we call these a baseline. Okay? So for us, let's go ahead and turn the page on this. And this is all because we worked this out. So we call them principal meridians and baselines. And you'll see quite a few of these kind of stacked out and in your text. Let me see, I think they have a better picture of this on page 310, if you want to turn in your text to page 310. You'll see these little corners that are coming out right here, 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 here. Quite a few of them defined in east. West doesn't have as many. Those are all intersections of latitudinal and longitudinal lines. So, in essence, we're true scale on those points. Now, as we get off those points, our scale gets warped a little bit as we move to the next one. So what you generally are doing when you're doing a map system is your datum, we can't use the Greenwich Meridian. That's over in England. We can't see that. We can't measure from there. Okay. So we look for an intersection of something close to us. We can't use the equator. We can't see it over the horizon. We can't measure from it. So here is my baseline, or latitude. Here is my longitudinal line. Ours is called the, does anybody know which one we use? It is the Boise Meridian. Okay. Now it's actually in the town of Kuna. Okay, it's this one right here. So that is our baseline. And what you're going to see on a property line, so I've got a property description right here. In essence, when we define that, notice the very first line here. Township 9 south, range 16 east, Boise Meridian. That's what you're looking for there. That Boise Meridian tells you where on the planet you are starting from. Now this property happens to be sitting in Filer. Guess what? Its datum is in Puna, quite a ways away. That is the initial datum used for this piece of property. But it's the closest meridian and baseline to us. Now, when you say, okay, well, that's quite a ways away. I can't really see Boise from here. We understand that. So we break this system down into township and ranges. So let's just kind of recap. We started with the planet, and we had latitudinal and longitudinal lines to divide the planet up. Now we've gone to the intersection of one latitudinal and longitudinal line, right here. Now that's still too big. We still need to break the system down more. And so if you turn the page one more, we're going to break it into this system, which is our township and range system. So townships go with our longitudinals. They come from a baseline. That's a township of 0. If I go 36 miles, that is another township line. So now I'm breaking this into 36 square mile sections. Ranges run east and west. Notice when they use the townships, they do a 1 north, 1 south. Okay? So it depends on which way you come from the baseline. The range comes from the longitudinal line. Or notice here it's going range 1 east, range 2 east, here range 1 west, range 2 west. So we can measure substantial distances both ways from these datums. Now, we then break it into a township and a range. Here's an example of one right here. A township in one range is 36 square miles. Or I should say 36 miles along a side, because that's not square miles. It's 36 miles along a side. Wait, no, hold on. Don't write that down, Sheriff. It's 6 miles along a side for 36 square miles.
Yeah, so, okay.
Okay. Boy, don't give me a piece of gum. I might just trip over myself up here and try and talk and remember these numbers. So there's 6 miles. Now that's still too big, right? 36 square miles, not many people own pieces of property that big. So from there, we then break it to a smaller unit called a section.
So the larger ones are townships?
Townships and ranges. Townships go north and south, ranges go east and west. All townships and ranges are labeled in this fashion, where it is now broken up into square miles, or what we call a section. Does anybody remember from your little conversion chart how many acres are in a section? 640. What's the length of side along a section? It's 1 mile.
1 mile.
Or how many feet?
500,280.
Okay. Now we're getting to equitable size for us. Because there are substantial amount of landowners that own a square mile, one of these. Now you'll always see them labeled this way, where they start with 1 in the top right-hand corner. Doesn't matter which one it is. This top right-hand corner or the northeast corner will always be section 1. Then it'll go to 6, drop down, 7 through 12, drop down, and it just runs in this manner. Every single one is done exactly like that. Now, many people still don't own a square mile. So we have to get smaller yet. This is where we go to the meets and bounds system, which is a traverse that totally encompasses the property. So in essence, what we'll do is we're dividing somebody's property, and this works down to a 1/4 acre, 1/8 acre, it even works smaller than that, is we'll generally always start the survey from somewhere on one of these corners. And folks, every one of these corners throughout the West has been surveyed in the West, every one. Okay, I found these things in the darndest places. I found them in mountains, 100 miles from the nearest road. You remember the CCC Corps, the conservative corps that one of our presidents did right after the Depression to kind of try and put people to work?
No.
That's Franklin Roosevelt.
What's that?
I think it's Franklin Roosevelt.
Was it Franklin? Okay. But anyway, it happened way back when. The 30s is when it was started, went up to the war, and then of course they had use for all them young men and women. But they kept going for quite a while even after that. One of their jobs was to survey the West. And so you will see brass caps out on there where they've placed these things. They've drilled them into rock. Some of them aren't accurate anymore, right? You put it in a rock and the rock splits and falls down a mountain. That happens. But they're everywhere. We have many of them right around campus. When you're driving around the country roads and stuff, sometimes you'll drive a road and you'll see all of a sudden somebody dug a hole in the middle of the road. That was probably some surveyor locating one of these corners that has been paved over. And it's sitting underneath the asphalt. Okay. So they're all over the place. We'll start a survey from here because we've got all these datums sitting throughout our country. So we can start there. Now, if I'm dealing with a little 1/4 acre, what I'll do is probably walk somebody in a path till I get to a point like here, which will always be labeled the point of beginning. That's where the property starts. And then I might do a little traverse that then actually defines the property.
So the point of beginning is not the corner, it's the one you walk to.
Exactly. Okay. So let me kind of recap. We start with the entire planet. We break that up into latitudinal and longitudinal lines, or we divide the planet up into those many squares. We find the intersection of those, and we divide that up into 36 square miles called townships and ranges. Then we take a township and a range and we divide it up into 1 square mile pieces called a section. Those are our datums for individual property. At that point, we start a meets and bounds legal description to define the property boundary.
The reason why they're using 6 and 36 is because of it's in minutes. And that's what,
You know, it is a degree minute second angle measurement. I'm not entirely sure, Cheryl, on exactly why it is in units of 6.
well, if you divide it by 10, then you're left with 6.
That might be a nice little search on the internet and see if you could determine the background of this. I've never taken the time to look up
So-
on the reasoning behind this. I think I did read one article, and I don't know if it's true, that Ben Franklin's the one that kind of instituted this in America.
So you're saying every mile walk, or, I mean, every one of those is survey, not the 6 mile one? I mean,
Every one of those,
every single mile one?
yes.
Whoa.
Okay, now before I leave this picture right here, remember how I told you on a baseline and a meridian, you are on true scale for the planet? Okay. That's why we use those things. So right here is a principal meridian and a baseline. So this is where a longitudinal and a latitudinal line crosses. This is where you're on scale. Now, that's the only place you're on scale. Well, I shouldn't say that. Whenever you're on one of these lines, you're on scale. Now, as we pull township and ranges off, notice this little deviation that occurs right here. So these lines don't line up. Boom, 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 boom. Well, once we get out far enough, we do a correction, and we do it every 24 miles. They've got it labeled up here. You see this in action in our area. If you folks are out there driving and you're on an east road, how many times do you hit something like pole line and you're driving that thing and then you gotta take a little turn to get onto the one across it? Because pole line's one of our correction lines. And if you drive that far enough and it takes over 100 miles, then you're gonna you'll see these roads as you come in. They'll get off, get more off, get more off, get more off as you go mile to mile to mile. And if you drive far enough, you're gonna see one that lines perfectly up. And that's where it has been corrected, okay, after 24 miles. So you might have one out in Buell, the next one's gonna be in Twin, or even further, because they're a little closer than 24 miles apart. Okay. So we correct those. And that's taking that scale. As we take that sphere and unfold it into a flat arena, we've got to correct these things as they go along. Because if you call this section corner out there, are you really there? No, you aren't. Remember we talked that accurate and precision part? You're actually precise, but you're not on the bullseye. We still think it's good enough for property description because every time we survey it, we're going to be that unit off. Okay, so it still works for property lines. There are corrections that do occur. Now, that's something if you got into surveying and you wanted to be a licensed surveyor, you would study this in great detail. Okay. For us, we generally don't get that far. Now, let's kind of look at this legal description that I copied all of you, and let's see how this process works. What in essence you're going to do when you do these is you draw them backwards. So you draw from the bottom. They're actually given, they start large to small. You're generally concerned small to large. Okay. So if you look at the very first line here, Township 9 South, range 16 East, Boise Meridian. Okay. Now, can you tell approximately from the Boise Meridian, which is in CUNA, that's a crossing of a latitudinal longitudinal line, how many approximate miles are you south and east of that point? 16. So we're in, remember, townships go north and south.
Yeah, so you get 60.
Okay, so this one's in Township 9 South, and there's 6 miles along the side of the township.
Oh, I see.
So you take 9 times 6, we're about approximately 54 miles south of that point. We're also 16 times 6 That'd be 60, 36, that'd be 96. We're approximately 96 miles east of that point. So that's kind of your XY grids, right? It tells you you're coming from the Boise Meridian, and it also sits in Twin Falls County. So it's starting big, right? Getting you to a smaller point. We've gone from the entire planet with this one line down to how many square miles? 36. Okay. And in fact, if you add the next portion, the next two, section 20, you've now gone from 36 square miles to 1 square mile. So you see how it's kind of zeroing you in here? Now, it then comes into this section right here. A parcel of land located in the northeast quarter of the southeast quarter. What the heck is that? It is a fractional system used for small pieces of property. All property that is less than a certain amount of acreage will go into that system. Okay, so let me kind of stop there on that legal description. Let's go back to your text and go to the next page, this one. And I think this is on page 312 of your architectural text. Now, this is one section. Okay, so the outside of this is 640 acres. Now, what we then do is we start parsing this thing out in rectangles. And we do it where we're doing even increments. So you always start with the overall shape, this one. Now from there, we are going to use a fractional system to divide this up, but it is really up to you on how that fractional system works. Now, if I'm dealing with a piece of property, I did something like this. How I would call this out is section, let's call this section 15. Okay. This would be section 15, and it would be the north half. This is all before the meets and bounds legal description. Okay. Now, why would I call the north half out? Because I know I'm in section 15, this guy. But the property is only in the north half of it, right? If I've got this block and I draw this line here, I've got a north half and a south half, don't I? So now I'm going from 640 acres to 320 acres. These are all just kind of ways to zero us in on where we're going. Now generally, that's still a pretty big chunk of land, still where most people don't own. So we generally break it into halves or quarters. I drew lines where I'm now in a quarter system. Okay. Now let's say we're dealing with a property that sits right here. When we write these, start at the small. Okay, so this piece right here, can I now take this and divide this up into quarters? Like it's shown here? Yes, I can. Okay. So in essence, I've got my original square broken up into quarters. So what quarter is this one right here? It's the southeast, right? Then I took that one and broke it up into quarters, and this is the northwest. Okay. So this would be, and you start small, northwest quarter of the southeast quarter of section 15. Does that kind of make sense? You can keep breaking these things down as small as you want it. Okay? Because here's a quarter. I can break this into quarters. I can break this into quarters. I can break that into quarters. I can break that into quarters. Just a way to kind of narrow us into the location. Now, this thing will always stop when it doesn't include the property. So these quarters must completely describe the enclosed to the property. Okay? So if I have something that comes, like let me say a little piece of property that's right here, well, I can't go to this last quarter because it doesn't do it. I could do a half. Whatever the case might be.
So if you had property that was,
So then we south half.
here, you would have had to stop at the east half.
Yes. Okay, so let's draw a piece of property. And let's say it goes something like this. Okay? So there's my piece of property. Okay, now, how am I going to narrow somebody down to this? Let me kind of erase a bunch of these.
Southeast corner.
Remember, what you're trying to do here is really get them as close as you can. So the first divider you're probably going to do is this one. So I'm going to break it in halves. Now I have a west half and an east half. Okay. Now I'm going to look, can I now do it something else? Okay. So this is going to be the east half. Now, can you break it down a little bit more, though? Okay, now remember, we kind of got to stick with the system. So I'm going to draw this and break this into quarters. And this one